we're going to introduce a vector space. Suppose you have a bunch of vectors, v sub 1, v sub 2, v sub 3, and more, right? So you have a lot of these vectors, for example. We can actually take these vectors and define a space that we call vector space. To define a vector space, that vector space must satisfy some important axioms. So let V be a set of vectors where addition and scalar multiplication are defined. So remember addition of vectors. If you have vector v, which is equal to, for example, a and b, vector u, which is c and d, u plus v or v plus u is equal to, you're adding the first components and then you're adding the second components. So this is vector addition. The scalar multiplication is just multiplying the components by a scalar. So suppose you have a scalar, like, for example, alpha, and you're multiplying that by vector v. It means that you have alpha a and alpha b. So you have a set of vectors with these two operations defined in that set. If the following axioms are defined or are satisfied for every vectors like u, v, w, and the scalar c and d in R, then we call V a vector space. So for now, it is just a set of a bunch of vectors. If it satisfies the following, then we call it a vector space. So first of all, V is closed under addition. It means that if I take two random vectors and add them together, it still is in V. So closed under addition. Two, addition is commutative. U plus V is the same as V plus U. You have associative property 3. It means that if I add 3 vectors, it doesn't matter if I add the first 2 or if I add the second 2. U plus V plus W is the same as U plus V plus W. So this is called associative property. 0 vector is additive identity. U plus 0 is 0 plus U equals to U. Additive identity. You also have additive inverse. For every vector U, you have minus U, that when you add these together, it's the same as negative U plus U, which is 0th vector. We call this property additive inverse. So these are for addition. We have some properties for multiplication, or basically scalar multiplication here. So number 6, V is closed under scalar multiplication. So C, U is in V, closed under scalar multiplication. Number 7, you can distribute scalar over addition. C over U plus V is CU plus CV, distributed property. Number 8, we have distributed property for the scalar as well. C plus D times U, the scalar multiplication, the sum of two scalars is scalar again, can be written as CU plus DU, again, distributive property. We also have associative property in the sense that if you multiply C by DU is the same as multiplying CD by U. So associative property. Also, you have scalar identity. 1 times U is equal to U times 1, which is U. This guy is called scalar identity. So note the difference between additive identity and scalar identity.